10 area under a curve. Now, so we talked about the purpose of integration, and one of it is to find the area under a curve. And in this case, we are looking at the area under a curve bounded specifically for the x-axis. All right, x-axis. Now, it is possible for the area to be bounded to the y-axis, but we will not do that in this video. We'll probably try that maybe back in class. Okay, so let's look at the concept here. So if we have some function fx, where y equals fx, so basically if we're going to integrate the function fx from point A to point B, we are basically finding the area under it. And this is very similar to what we have done before, which is definite integral. All right, so we are integrating from A to B of fx dx. We should be able to get the area. Okay, so this is the concept. Now, sometimes your graph, maybe if I were to draw it, something like that, maybe your graph is under the x-axis. All right, so let's say this is point A, this is point B, and this is y equals fx. Now, no problem. Even if it's under the x-axis, your area can be found, even though your area may appear to be a negative value. But yeah, we will take the area as a positive at the end. All right, we're going to have some example to show you how that works. All right, and yeah, so let's go through some examples. I think that's the best way to learn. All right, let's look at example 19. All right, we want to find the area of the shaded region. Basically, we need to integrate x squared, right? And from 2 to 3. All right, so we can say area is just equals to the integral of from 2 to 3 of x squared dx. Again, bounded by the x-axis. So we evaluate that. So that would be x cubed over 3 from 2 to 3. And we work that out. So what do we have? 27 over 3 minus, this should be 8 over 3. All right, so express in your calculator, you work it out, it should be 6 1/3 unit square. Because it's area, we just use unit square to represent the area. Okay? All right, so this is a very simple example. I hope it's clear. Let's look at example 20. Now, you can pause the video and try it yourself first, and then check through your answer, or you can just listen to how this is done. All right, those of you who want to pause, you can pause now. Okay, so let's find the area. So we are integrating this, the boundaries from 1 to 3, and my function is 1 plus e half x dx. Okay, so let's integrate that. You should be able to get x plus e half x divided by the differential of half x, which is half. Okay, and we are integrating it from 1 to 3. Very similar to definite integral. So we work that out. We should have, let's see, 3 plus 2e 3 over 2. Okay, minus, substitute 1 in, should be 1 plus e to the power of half. So divide by half, so this should be 2, yeah. Okay, so we are here, we can just evaluate that, press it in your calculator. All right, you should be able to get 7.67 unit square. All right, leave your final answer in 3 significant figures. All right, so basically this is the area under this curve. All right, let me know if you worked it out yourself and you actually got the answer. All right, let's look at example 21. So this is an example, like I mentioned earlier, where the area is under the x-axis. Now, no worries, we will evaluate that area and we'll change it positive, basically. All right, so let's work it out. So area for this is basically, if we're going to integrate this, would be from 0 to 3 of x squared minus 3x dx. So work this out, should be x cubed over 3 minus 3x squared over 2, and we evaluate that from 0 to 3. So plug in all the value in, we should get 9 minus 27 over 2 minus, if you're going to put 0, I think everything is 0, right? So our answer is minus 4.5. So area cannot be negative, right? So we will basically say that the modulus of the area, meaning to say I'm going to mod this whole thing, okay? That should be basically, just put a mod sign all over through, over, so the answer will be 4.5 units squared, okay? So positive value. All right, so in general, if we are looking at area below the x-axis, we can say that the area is equals to the mod of the integral from a to b of fx dx. Okay, so this is a general rule. Oh, my line is not really straight. Okay, there you go. All right, so you can use this formula to help you, especially if you know that the area is under the x-axis. If you can't really tell because you don't know how the shape looks like or the graph looks like, then if your area turns out to be a negative value, then you just add the mod sign to the whole working to convert it into a positive area. Okay. Now, let's look at example 22. Now, this example is a bit different in the sense that you see that the graph is split into two parts, right? If you want to find the area minus 3 to minus 2, you will notice that the area is negative. And if you evaluate from 2 to 3, the area is positive. But again, area, there's no such thing as negative area. So what we will do is we're going to evaluate from minus 3 to minus 2. We're going to mod it, get a positive answer. And we're going to add it to 2 to 3 so we can get the combined area. All right, so let's try this one. So if we're going to integrate from minus 3 to minus 2 of 1 over x dx, we should be able to get ln of x from minus 3 to minus 2. All right, and we're going to add it with the area from 2 to 3 of 1 over x dx. So that should be equals to ln x 2 to 3. All right, substitute in. This would be ln 2 minus ln 3. Sorry, yeah, ln 2 minus ln 3. Okay. Why I put positive? Because mod negative will be positive anyway. So I just put positive straight away. So this would be ln 3 minus ln 2. Okay. So that is how you find the area. Okay. Now you'll be thinking, what is the if you add these two, wouldn't it be 0? If you think about it, so minus 2 minus ln 2 is 0, ln 3 minus ln 3 is actually 0. So what is going on here? Okay, now it appears to be 0, right? But actually it is not 0. Let me explain to you. All right, so if you were to evaluate this, this actually will be ln 2 over 3. And this would actually be ln 3 over 2. Okay, now these two values will be actually positive value. All right, so that is why when you add them together, you actually will get a positive answer. Okay, so yeah, I hope that is clear. Okay, if there's no problem, then I hope everything is all clear, there's no issues, and yeah, I will see you in the next video. All right.